Hello and welcome to part 3 of matrix multiplication. Now today I thought I need to do some problems. So let's say find 3, 2, negative 1, x negative 2, 1 and 3. So find this multiplication. If you have not watched the last two parts of matrix multiplication, I recommend you watching that first. Now, first row with first column, this is the order. So we get 3x plus 2 because this number with this and this number with this, and then you add them. That's how you multiply. And this is 2 by 2, this is 2 by 2. And yes, these two numbers agree, and the resulting matrix is given by those two corner numbers. So that's going to be again 2 by 2. Now 1 into 3x plus 2, second entry, that's going to be this row and this column. So 3 and negative 2, negative 6, 2 and 3, 6 is 0. Now we are done with first row of first matrix. So now with the second row, this into this, so negative 1 and x, you get negative x, and then x and 1 positive x, so 0. And this row with this one, so second row and second column, so negative 1 and negative 2, that's 2, and plus x into 3, so 2 plus 3x. So actually now I can pull that out, 3x plus 2, because it's the same, and I'm going to get 1 0 0 1, right? That's a simple nice problem. And let's see another problem. Let's say the matrix A is this 1 2 0 1. Again, when you watch these videos, I recommend you try it first by yourself. So the question is, find part A squared, part B a cubed, part C suggest a form for a raised to k. Okay, now let's have a look at this. So this is the problem. Now solution. A squared, so part A squared is A times A, so you have to write down A twice using multiplication. So this row with this, so 1 and 1 1, 2 and 0 0, so 1. Then this row with this, 1 and 2 2, 2 and 1 2, so 2 and 4. Now this row with this, so 0 0, and this row with this, 0 1. Part B, a cubed, a into a into a. Now at this point you don't have to, this is actually a squared times a, right? You already found a squared, this guy is a squared, so you can write it here. So that's the easiest way to go. And a 1 2 0 1. Now this row with this column, so 1 and 1 1, so 1 4 and 0 0. And this row with this column, now 1 and 2 2, 4 and 1 4, so 6. Now this row with this column again, 0 0, and this with this now, 0 1, right? Now we see a pattern. Look at this carefully. A is this, you have 1 1. Even in a squared you have 1 1. Even in a cubed you have 1 1. So for part C, the pattern I'm going to suggest for a K, the main diagonal is going to be 1 1, and right here 0, right here 0, right here 0, so you get 0. Now look at this number 2, and here it's 4, this power is 2, and here it's 6, power is 3, so it seems like you are getting twice as the power, so 2k. Okay, now let's see another nice problem. How about this? Okay, A is 1 2 3 1 1 2 3 1, and show that (2a plus 5i equals a squared). Now what is I? I is the identity matrix. Normally in my earlier videos we use I2 for 2 by 2 identity matrix. Now in this case you have to assume it is 2 by 2 because we are talking about addition here. A is 2 by 2, so here this I is actually 2 by 2 identity matrix. Now let's do this again. Pause the video and try it for yourself. Assuming you have done it, now left hand side, you take left hand side, that is 2a plus 5i, so 2 times this plus 5 times I is this, right? This is going to be, so 2 4 6 2 5 0 0 5, and when you add, you just have to add those numbers, so you get 5 and 2 7, 4 and 0 is 4, 6 and 7, right? Now right hand side, a squared, so 8 times a, 1 2 3 1 1 2 3 1. So first row with first column, 1 and 1 1 2 and 3 6, so 7. See, I got this, good. And first row with second column, 1 and 2 2 2 and 1, again 2, so 4. See, I got that. Second row first column, 3 and 1 3, 1 and 3 3, 3 and 3 6, good, I got that. And last one, let's see, 3 and 2 6, 1 and 1 1 7. See, I got all four. These two are same, so we have proved this one. Okay. How about this? Let's say A is P 3 6 and P. Now this is a nice problem. This is a problem that will provide an answer to one of the questions that I asked you in previous videos, and I kept that problem open. This partially answered, that's a very general open question, so show that AB equals BA. Now let's first do this, then I'll talk about that. Again, pause the video, try it. So these 15-20 minutes videos, for you it should be more than that, 30-40 minutes. Now what you need to do, just find AB. So they both 2 by 2, so you can find this Q2 for Q. So first row, first column, Q squared, Q into Q, Q squared plus 12. First row, second column, so 2P plus 3Q. Oops. So 2P plus 3Q. And second row, first column, 6Q plus 4P. And second row, second column, 12 plus PQ. Right? and then BA. Remember, matrix multiplication is not commutative. That means the order matters. But in this question, they are actually asking us to show this one particular example that it is commutative. Let's see. P36B. So first row's first column, P and Q, PQ plus 12. And first row, second column, so 3Q plus 2P. Let me see. Okay, I think I have made a mistake. Did you notice that? Yes, right here. What happened was I read this as Q, so this into this PQ plus this into this 12. So it's not Q squared plus 12, it should be PQ plus 12. So that's why I was wondering. So here PQ plus 12. So far so good. So this is and this is same, this and this same. Now next, second row, first column. So 4 and P, 4P plus 6 and Q, 6Q. So 4P plus 6Q, that is same as this guy, see, so they are the same. One more to go. So this row and this column now, finally 4 and 3, 12. And Q and P, PQ. See, they are the same. So that AB equals BA. Now, if you can remember, in my part 1, I think at the end of I posted a video, I posted a question, can you find two square matrices such that AB equals BA? And we talked about a little bit about that question in part 2. See, in this A and B, none of them are I. A is not identity matrix. So this is not a trivial solution. There is a pattern. So not just that actually, because it's in terms of P and Q. So this actually provide infinitely many solutions for that open problem. So what you need to do, you need to replace, like, let's say if P is 1, 1, 3, 6, 1. This A, and if Q is 10, so 10, 2, 4, 10, this B will always commute. AB equals commutative, AB equals BA. So we'll talk about that question in general later. Okay, let's go and do one more problem. Okay, let's say A is 3P, negative 4 and Q, and A squared is I. Find P and Q. Okay. Again, pause the video and try it. Assuming you have done it, solution. So A squared, what you need to do, 3P negative 4Q, 3P negative 4Q. So let me choose another color. So this row, this column, so 3 and 3, 9. This and this, so minus 4P. Next, this row and this column, so 3P, 3 and P, 3P, P and Q, so PQ. Now this row with this column, so negative 4 and 3, negative 12, plus Q and, so negative 4P, negative 12, negative 4P. Wait, negative 12, negative 4Q, you have to be careful. And then finally this row with this column, so negative 4P, plus q squared, right? Now it's given that this guy is equal to identity. So now this will create 4 equations. This must be this. So 9 minus 4p should be 1. That's the first equation. This guy should be this. 3p plus pq should be 0. This should be this. So negative 12 minus 4q equals 0. Finally, this is this. So minus 4p plus q squared equal 1. Now what you need to do is solve them. Actually, you just need 2 of them because you have 2 unknowns and 2 unknowns. So let me, you know what, let me take another color and let me take this. So let me label them 1, 2, 3 and 4. So from equation 1 it's clear 4p equals 9 and p equals 9 over 4, right? And if I use equation 3, from that it's 4q equals negative 12. Now from that q is going to be negative 3, right? So using equation number 1 and 3 I found p and q, but I have 2 more equations, so let's check. Equation number 2, 3p, so 3, p is 9 over 4, let's check our solution, plus pq, p is 9 over 4, q is negative 3, is 0. Let's see whether this is 0. So as you can see these numbers 3, 3, 9, 4, this number and this are, you know, this is positive part, this is negative, so it's 0. Can you see that? 9 over 4, 3 of 9 over 4s here, negative 3 of 9 over 4, so that's 0. And number 4, let's check that as well. So minus 4p is 9 over 4 and q squared, q is negative 3, so q squared is 9. Let me see, q squared, did I make any mistake there? Minus 4p plus q squared. Something seems to be wrong here. Okay, let's do one more problem. A 3p negative 4q and it's given that a square equals I. Find p and q. Again, please pause the video and try this. You know, one key is to write these things clearly so you can do the calculations, simplifications. They are not hard. Now a squared. So 3 times 3 plus p into negative 4. So 9 minus 4p. And first row and second column, 3 times p, 3p, p and q. So 3p plus pq. 3, see, this into this and this into this. So 3p plus pq. Then second row, first column, so this into this, negative 12, and this into this, negative 4q. Finally, this into this, so negative 4p, and this into this plus q squared. And it is given that is I, so 1 0 0 1. Now we have 4 equations. This guy must be 1, so 9 minus 4p equals 1. So let me call it equation 1. Actually from 1 I can straightforward solve for p, right? When I subtract 1 I get 8, minus 4p equals 0, and 4p equals 8, and p equals 2. So we already found p. Now this guy must be 0, right? So negative 12 minus 4q equals 0. So from here, when I take 4q to the other side, 4q is going to be negative 12. So q equals negative 3. Using only 2 equations, I found p and q. So I used this part. Now let me use this and check my solution. So 3p plus pq, that must be 0. Let's check. So 3 times the p that I found was 2 plus p2, q was negative 3. C, 6 minus 6, that is 0. And yes, correct. Last one. This one must be 1. Let's check. Negative 4p plus q squared. Negative 4 times p was 2 plus q squared. Negative 3 parentheses squared. And negative 8 plus 9, which is 1, and see here it's 1, and that's correct. Okay guys, I think I have done a good amount of examples, so let's do more theory part from our next video onwards. Thank you.